Jim, why don't you tell us a little bit? We're recording now, so tell us a little bit for the benefit of the viewers, what exactly Chem Concrete admixture is and how it's a game changer.
Wow, that's a big opening question. Don't you want to hear about my childhood or?
Are you still riding a bike? You were kind of an athlete, eh, with your bike. Why don't
Boy,
you talk
kind
about
of,
that?
yeah. Now you're going now. Okay, now you're touching a nerve. Yeah, I'm fat and old now. I wasn't always fat and old, if that's what you're trying to say. Yeah, no, I don't get out much these days. I'm running pretty hard. I get up early. Obviously, I got to wash Boris's car. I've got to do all the chores and stuff. So I don't get to exercise as much as I like, but yeah, pretty busy these days. I gotta say, right, Boris? I don't know if there's any way around it. We're all running kind of hard. It's been a lot of fun, but yeah, we've it's been interesting. I think, Martin, you were kind of involved there in the beginning, and anytime you talk about an endeavor and you just say, okay, well, you just take these six ingredients and go mix them together, and then, and it's like just that one sentence alone is like 2 years and a massive learning curve, and you get into shear blending, emulsifying, get into high electronics, 240 volt versus 480 volts, and triple phase, single phase. Everything's been a journey, but I think we're kind of through the valley, Boris and I. I've got some juice in a bottle. I think Boris comes online here. He had a pretty tough winter, but we're very excited. Yeah, we've got some stuff in tanks, and we're ready to rock and roll. So we've been talking a lot, and again, I don't mean to make light of that. Sam, as you know, Sam, his wife, and his team there in Australia, they all have PhD after their names. Blue Blazers, smart folks, very well published. Of course, Murtosh, everyone knows him, probably the most popular engineer in the world on LinkedIn. Good group, well tested, well researched. And it's just up to Boris and I to kind of mix it together, get it in totes, get the demand. I think we've had a lot of demand. And again, not to be holier than thou or sacred or anything, but we're trying to be very selective. Obviously, where I live here in Southern California, there's several different layers, stratas of concrete that gets installed every day, some of which you very much want to be a part of, and other concrete you probably would rather just step aside and let them kind of self-level it up or whatever they're doing. But yeah, we're very excited. Every time I think we test it, right now we're in the portion I just gave away about 500 gallons, usually 5 gallons at a time, sometimes 15, sometimes 55 gallons at a time. And everyone that tested it, I had one gentleman, I think he tried to test this in some Mag Fos based cement, and he kind of came back, Jim, and I get that. We're not really, we're not the fix for everything, but everything with concrete and geopolymer modified concrete, I'd have to say the reception has just been very, very good. Everyone's been very warm. We try to undersell it. I'm big on that. I have a chip on my shoulder, right? I'm old and fat, like Martin astutely pointed out in the
I
beginning. God bless you, Martin. And then we have really poor material here too in Southern California. I use the word crappy quite a bit, kind of vulgar, but kind of accurate. So we want to bring our technology, and we like to, always kind of under promise, over deliver, test it with your material, your cement, your aggregate. I can't stress that enough. We're not performing magic tricks here. You got to kick the tires, but you got to do it with your stuff. I can show you stuff from all over the world, Australia, Southern Cal. If you live in, Sudbury, where Boris is at, he doesn't really care about my material. He wants to see his results, his material, his cement, and his mixture of admixtures. And we can talk about one else cements and Pozzolans and all that different stuff. But that's where the rubber meets the road. And with the grace of God, everything has been outstanding to this point. So we're very, very excited.
So for the benefit of people listening in, Jim Kaylor is officially Chem Concrete USA, and Boris is pretty well got the full Canadian scope. How's it going, Boris, with different parts of Canada? You
Well,
you've got a big country there.
yeah, we do. So let me go back and sort of add to Jim's introduction. So Chem Concrete is, I would say, a revolutionary admix that is a step change in the admix world in how it enhances concrete performance. And that's what I think has us all excited about really bringing it to the North American market. Basically, it'll tackle a couple of key issues. One, the whole concrete world through the cement world has got a scar on it because of our environmental impact, which is created in the manufacturing of the raw material cement, which creates greenhouse gases. By using the Chem Concrete additive, it gives us the opportunity to actually reduce some of the cementitious content and therefore making our concrete mixes more environmentally friendly. The other item it does is it improves performance tremendously from a waterproofing perspective as well as a compressive strength perspective. So we have the ability, like Jim said, to work with the different materials across Canada and get some phenomenal results.
How are other countries doing? I mean, you must follow and get the news from Sam about because he's got a world patent there. That's my
He
understanding.
does, and that's as you know, that it can be a good thing, it can be a bad thing, kind of a double-edged sword. You're kind of boiling the ocean, I guess is the term I like to use. We brought our Chinese facility online. I know Sam and his wife and his team has spent a lot of time there. And as anyone knows, China's got some, again, very positive, but you got to babysit, you got to, check every box and stuff. But looks like we're going to have a couple of key facilities around the world, China being one of them, where we gather our natural raw materials and we're able to kind of pre-measure and put it together, the formula. So when the time Boris and I get it, we have to manipulate it. We have to, of course, manufacture it at our spot. But it's going to be a little easier. It's one thing. It's like we always went back right to the beginning of SAM. They center around that Western Sydney University. And sometime, 15 years ago or something, they kind of stumbled into this formula and said, wow, if you could commercialize this, you'd really have something. Well, in doing so, you have to make it so guys like Boris and I can also make it in abundance, make it in a very strict tolerance, have a really narrow distribution. We don't want it, Boris is off here, I'm at a different level. We want everything to be in harmony. And there's a difference. We walk if I always tell a story, right? You walk in at your favorite quality control manager, you take him to lunch, and you're in his office, and undoubtedly every quality control manager that I know has a cylinder on his desk, and he's always, Jim, that cylinder, I can get to 22,000 psi. And you always hear that story, and you're like, that's great. What's in it? Well, we got steel fibers, we got silica fume, we got this and that. And you say, okay, and that's great. And how much does it cost? Well, it costs like $2,000 to make. I'm not talking about cost, Jim. I'm just talking it's 22,000 psi. And you're like, okay, and can you make that as just within your system at a normal dry batch overhead transit mix plant? Well, no, of course not. I got to make it in the lab, Jim. So we always have that what works in the lab sort of thing. We call it lab Crete, and we've all had experience with that. And then what you can take on a massive production level where you can fill trucks consistently, ready mix concrete, or a precast plant, something like that. Consistency, that's your key, right? So um, Boris and I are tasked with that. And like I said, it's been a journey, but I think we kind of got a tiger by the tail. And I think we're doing a pretty good job so far. So we'll see.
Yeah, I would say so. You're not going too fast. You're being careful. Now, I saw some test results. I don't know if it was LinkedIn, Jim. I think it was you that talked about 7 and 8,000 psi, and I think that's with arguably less cement. Than I mean, would you not agree that your 5,000 psi cement levels, is that approximately what you use? And it's
Well,
still,
yeah, that's a good question. You know, you talk about the LinkedIn universe, right? We could talk about that probably for a couple hours. It's a very eclectic, very interesting bunch, right? I mean, look at yourself, Martin, you know, highly uh, proven, you know, skilled professional engineer. You've got researchers on there. You've got guys like me who, at the end of the day, let's face it, I'm just a peddler. So, you know, everybody's kind of on there pushing their wares. So you have to be careful. But yeah, I think Boris touched on it. We're coming at the market in really two-pronged approach. One is yes, at a lower dosage, if you will. So you're back to like a low, mid-range, high-range plasticizer, right? You might ask for 2 to 3 ounces per hundredweight. We can come in at about 2% cementitious. That puts us plus or minus 1 gallon a cubic yard, or in your universe, 5 liters per cubic meter. We can pretty much compete and compete with just about anything out there. The Crystal Growth folks, there's, I don't know what you would call kind of an exotic, a high Crete, Cortec, something specifically designed, you know, towards the steel and concrete. We can compete very well, we feel, across a broad spectrum of testing, whether it be waterproofing, corrosion resistance, shrinkage reduction, a number of things quite well. Then we go to what we call our ultra spec, 2 to 3 gallons a cubic yard, puts you up anywhere from 3 to maybe 5, 6, 7% cementitious, depending on the mix. And that's where we get to show off, and like Boris touched on, we are pretty consistent now, up to 35% cement replacement. And again, that's 35% cement replacement. So 1/3 of your mix design, we come in early and sit down with the QC guy, right? Because nobody knows that mix better than that local QC guy. And we can pull out a significant amount of clinker out of a mix. And we can achieve similar strength results, compressive, flexural, all the normal results. So I have a bench mix. It's a local 5,000 PSI mix here in Southern California, pretty similar to just about every company out there. So obviously in LA, besides being a little cuckoo, we have very expensive dirt, right? So the norm is to park underneath. So you might go down 2 or 3 stories subterranean, you park, and then you build up podium deck. This would be pretty much standard close to every podium deck in Southern California. So 5,000 PSI mix. Now we do a couple of things. One, I think you saw lately, we pulled out 35% of the cement, and at 28 days, we came somewhere around 55, 5,600 PSI. So that basically we just kind of put our money where our mouth is. We just proved it. The second thing, because we do the things that we can do, is you kind of get pulled in different directions, right? So naturally you look at the ultra high performance concrete market, which is what, 120 MPa and over. So we can get you right into that space pretty quickly. And that brings up different fibers, right? By definition, you have to really throw some fibers in there, ultra high performance concrete. We've been playing with some of the basalt fibers we like a lot. It's not so much a fiber, it's almost like a bar, a small bar, a stick, if you will. It's got a helix type shape to it. It's nominal 41, 42 millimeters, so probably what, plus or minus 2 inches. It's got a heavier specific gravity than water. It's like 1.09, so it doesn't tend to float up as much as, say, polypropylene or some of the other fibers. And we've gotten very good results with that. We'll take a modular rupture, right? We tip a cylinder over on its side, and we get very good results with that. With that said, there was a mix the other day that came out. I was a little irritated. I think it was a Friday afternoon. The guys got lazy. And we basically just kind of went to sleep and we blew the slump out. So we lift the slump cone up and the slump just goes off the table. Not a true SCC, a self-consolidating mix, but you know, pretty close. That's the gist of it, right? So we take a 5,000 PSI mix, which normally would be down around the 2,500, 3,000 PSI level. And you're exactly right, Martin. I think we came in around 6,000 and change at 7 days. And around 7,500, 8,000 or something like that at 28 days. So pretty outside the box. Now, again, as we talked about the eclectic nature of the group on LinkedIn, I get a lot of, Jim, that's an ugly SCC mix. Well, yes, it is. It wasn't designed at SCC mix. And so you get all the different, responses bouncing off of you. I in no way, shape, or form want to try to challenge my friends to go out and take their mix and wet it up and piss it in. That's not what this is about. What this is about is the margins, right? You have a mix, a QC guy over designs, maybe 10, 15%, and he expects it to fall in that range every time. If you add too much water and destroy the cement matrix, you've got a mess. So again, I want to make sure my guys don't take it as a challenge. Like, gosh, Jim says we can just add, 50 gallons of water to every load and piss it in. That's not what it was meant for. But as we dig down, and I don't think we've really, Boris and I have really established the upper limits of what this little admixture can do. It's really, in my mind, quite remarkable. I don't like to get too hyper dramatic, right? That's the other message, right? We want to sell a lot of admixture without sounding like an admixture salesman. And some of the younger guys probably don't know what that means, but admixture salesmen have a certain persona that they've acquired over the years. So, like I said, we want to under promise, we want to over deliver. And to take a mix like that you basically destroyed the slump and come out something that strong, pretty special. Yeah.
I got a quick
Now,
question. So the
go
admixture you
ahead.
guys put into the admixture you guys put into concrete, right? Your Chem Concrete. Can you, in theory, instead of doing like a 12-inch pad for strength because it's whatever, or a road or whatever, are we able to shrink the pad now and still have the same strength because we're adding to the mix?
That's a good question, Brian. And I could tell you, but then I'd have to kill you. So I kind of no. Those are good questions. Yeah, it depends, I guess, is the bottom line. I know, like in warehouse slabs, we've
Yeah.
seen a pretty strong learning curve, right? These guys like Greg Skirdo and stuff, Ductile Crete, they're moving the joints out one, and now they're starting to thin out sections. So you have to be careful. I think if you do the basic engineering, and Martin, correct me if I'm wrong, it's like between a 4-inch thick slab of concrete, you have a certain load bearing capacity. If you go even 5 inches, that load capacity goes up dramatically. I think it's what, 25, 26, 27%. So if you have something that, say, a structural deck that you wanted to thin out slightly, you could do that if you were purely doing it because you need 3 inches of coverage over that rebar because Mother Nature, sulfates, chlorides, microbial, whatever type of corrosion is coming at your rebar. Yes, then we could close off the matrix. We could densify that concrete to the point that that would not be necessary. Load capacity, if you're doing like a warehouse floor and you've got some super high pallet jacks and you've calculating that load on the floor to take a certain amount of steel and concrete, probably not. So again, it would depend, Brian. I guess is the short answer.
And then
I
what
think I
about
think Brian, think about permeability. So the
yeah.
mix, I think one of the key things is what is this admix? And I believe it's all nano. So the nanotechnology is cementitious in its benefits, right? It's like putting more cement in, but it's more cost effective. So the nanotechnology, is it 5 or 6 hybrid, Jim? Is it?
Gosh, there's probably, I'm guessing at least 5 of the silicas that you would say, because you're exactly right, Martin. So there's a pozzolanic, and that's why we always kind of hesitate. And then I make the joke about, selling admixtures without sounding like an admixture salesman. We're checking so many boxes here that it does. And I mean, Boris and I have to remove ourselves. Sometimes it almost sounds like too good to be true. It's like you're selling snake oil. We're checking so many boxes here because we're taking This is a reactive admixture. That's the other issue Boris and I are dealing with. The material we have now is probably about a year old. So if you call me tomorrow and say, Jim, I need 10 totes, I want 3,000 gallons, I'm doing X or Y, the material you get is going to be quite a bit stronger, right? It would be just like if you went out in your yard and Boris went and found some clinker in a silo stuck in the back there, and he's got, 10 tons of cement sitting around that he didn't know about. It's not going to perform the same if it's a year old, right? As the stuff that comes in tomorrow. So we have a very unique formula. Yes, it's a liquid chemical admixture, but it's no different than like a fly ash or a slag. There's a reactivity to it. So we have that portion, as Martin mentioned. I think there's 4 or 5 different silicas in there. They're nano level, there's micro level, there's all kinds of levels. There's different kinds of, we like to use the word silica fume like. It's not technically silica fume, but it's awful close. And it is very reactive. There's some particle packing. Boris knows, right? His best mix is something that's got a super fine grade to it. It's got a lot of fines, a lot of middle, a lot of large aggregate, and then he works his cement paste around that. This is no different. We've got something that on the super small to medium small level, the nanoparticle level particle packing, if you were, plus the pozzolan, and then you throw the rheology in there. We cap it all off. We like to say a stout mid-range. In reality, it's probably more like a high range. In my part of the country, you say high range, the guys recoil, right? High range is expensive. High range is tough to finish. It's very sticky out here, like a peanut butter. So we kind of step around that. We call it a very strong mid-range package. But in all reality, all of these good things, these silicas, are wrapped up in a super plasticizer. So as Boris suggested, it's a rather unique thing, and we're checking so many boxes that we are very cautious, because even when I read it, sometimes you look and you're like, wow, we're talking like voodoo or magic. This isn't cement chemistry anymore. So we want to be very careful of that. We want to be very prudent in our approach.
The cements are the same, correct? Like you might reduce the amount of cement, but you got type 1 or, the typical Portland cement, right?
That's a good point too, Martin. I always want to be careful. I was down in San Diego a couple of weeks ago, and Tyler Lay was in town. And Tyler obviously talks in generalities. He's in Oklahoma State, so he has a certain kind of material. But again, these guys see a lot of different mixed designs from all over the country, all over the world. Type 1L has been around a long time. Type 1L is here to stay. We work very well with Type 1L. Are there problems with Type 1L in certain areas around the country, around the world? Absolutely. I think that's been made clear. We do not want to, those are kind of above our pay grade, right? We're not in a position, well, there's too many admixtures, 1L's bad and wet curing's bad and all that. We want to step aside from that. We like the way it is. We work just as effectively in a type 2.5, a type 3, a type 1L. There's one of the companies here, Cal Portland, a very good company, has a ternary blend where there's 3 different. There's some 1L, there's some obviously limestone ground in, and they use a natural pozzolan with their clinker. We work very well with that. We're going right along with the curve. These kind of pozzolan mixes, whether it's a natural pozzolan, you have a zeolite, a pumice, whatever you have. We like that. Our mechanics work in that whole world. And as Boris touched on, that's the wave that's coming. You can paddle against it, you can complain, you can cry, you can kick your, but it's here and it's coming. And if you listen to Tyler Lay, overall, I think it's worked pretty well. Are there spots where there's some issues? Do you have to come in some of your ACI practices that we've all taken for granted over the years and got lazy and sloppy and kind of, well, we don't need that. Do we have to look at them, bringing them back? Absolutely. He's got some very good test data. We talks about curing, and there's some waxes and PAMs and different things The old wet cure, boy, that's just twice, three times as good. So, you know, I think it's more of a matter of going back to the way we were taught maybe 30, 40 years ago and pulling some of that out and re-looking at maybe some of our blankets, our curing blankets. Maybe we got to go out and buy new ones or clean them up a little bit or something. But absolutely, the trend is there. We love the trend and we work very well with the trend. Put it that way.
Have you done
Yes.
anything with ductile Crete, Greg Skirtle? You done anything?
I would love to do something with Greg. I think he's a genius. And I think that kind of goes in part with what Brian's question is. We start talking about thinning sections over. I think steel fibers. I know the Forta family, the Linds, they bought that Helix company. I think you can expect some good things from them. That kind of steel fiber with that helical type twist to it. I like Nick's Basalt fiber, same thing, a bigger fiber, a little easier to finish. If you finish steel, you've probably got some stories and some scars to talk about. But yeah, we think that's a big area when you get into particularly sustainability, as Boris alluded to. But yeah, I mean, we're here today and we want to participate. We're working on an EPD, one for the USA, one for Canada. That should be out soon. Unfortunately, I share a large yard with a very large contractor, concrete contractor. So getting the water bills and electric bills is a bit of a challenge, but we'll have EPD here very soon, probably about the middle of June, and one for USA and one for Canada. So we want to participate in that. We think it's great. We love the direction it's going, and absolutely. If you want to thin out sections and stuff and you're an engineer, we would love to sit down. You get a good structural engineer and you talk about the load design of that slab. You give me a really sharp QC guy that's going to deliver and supply the concrete all day long. We can have a substantial, I think, benefit value proposition to that. If you want to absorb that benefit with stronger concrete, if you want to pull some cement out and use that strength to save, Mother Earth and less the carbon and energy footprint, no question about it. We have a very substantial proposition. We'd love to talk.
There's
How about,
also-
Dante, can you share that? I sent you an FEBTU lock section. Do you have it in your email?
Yeah, I can look
I know
for
I,
it. Which one are you
think
looking
it-
for specifically?
well, no, I mean, I just
Oh,
sent you an email.
Yeah, I got it.
So I just want to show Boris
Mhm.
what could happen with some large orders in Toronto. I have a patent, Boris, with a waterproof wall. So I replace secant piling, which is drilled circles, which is the dominant thing that Issued and other engineers, geostructural condos, this type of thing, for excavation support. So, Jim, I think you might have seen this before, but it's 2 5-inch layers of, now it's specified as Chem Concrete. So the anchors are put in with sacrificial steel, self-drilling R63 anchors, they're called. And then we do a bypass system. I started it as single bypass when I was at HCM, and now I do this double bypass, and I managed to get it patented. So this is a water management system. And if you have, there's fairly large volumes, we could standardize pretty quick, Boris, with anything in Toronto. It's not like, I mean, in my opinion, I had one engineer tell me, well, I'd still want blindside waterproofing, but with Chem Concrete, my idea is you don't need blindside waterproofing.
It's extremely dense. That's the reality.
Yeah, it's impermeable. So I still have pictures that Sam produced that show water beating on the concrete. So for the purpose
That's my
of
favorite picture.
yeah. So basically, Brian, you would have, it doesn't, like when you pour a slab of normal concrete, the water sinks in, right?
Correct. It absorbs.
So, but in a Chem Concrete wall, let's say, it would be easy to replace Blindside waterproofing. You don't need the waterproofing. And it already is a significant savings over Secants. So this is the market we're going after. And matter of fact, Nader Ansari, who's one of the key engineers at Ishwood, he's an owner. He's doing a talk this week in Toronto. And that would be a pretty good one to go to, Boris, because they're going to talk about the history of the bathtub. And the history of the bathtub in Toronto was that Toronto was overregulated. So they ended up, doing secant walls, where this system saves you $100 a square foot with the fact that 2 layers of shotcrete is a lot cheaper than big circles. Even if you put 5 MPa caisson wall mix in this wall around a site, which is 99 out of 100 jobs are done this way, then it would be, it's easy to see where the savings come, because you have a quality product. So we would do a better shotcrete, Brian. That's the idea here, that we,
And
you
that
see
looks
that
like a
section.
really, really great design, Martin. But again, like the first thing right in the middle of the page, a feather edge. Again, kind of going back to what Brian said, that's where we would have some tremendous benefit, right? You don't have feather edge is pretty thin, obviously, but yeah, we don't need a lot of concrete. Like Boris said, we densify, we disrupt that capillary system to the degree. I have a lot of experience here in, again, Southern California with waterproofing, which in reality, probably closer to damp proofing. Here, it's not so much when you do a lot of these walls that go down 2, 3, 4, 5 stories. We use a structural shotcrete. We have replaced a lot of primary waterproofing, mostly bentonite panels and such. Maybe an engineer will still put in some drain board. Maybe he'll chimney that drain board and skip a spot to physically evacuate water so you don't get a lot of buildup of hydrostatic pressures. But it's a little tough for me to say. I think, your neighborhood, Boris's neighborhood, probably a little bit different. But absolutely, it would be relevant if you could take, again, the thickness of your wall with the Chem Concrete. There's no question that the whole permeability plunges. We've done some testing, and that's what our guys have done too, Sam's team. Very extensive testing with some of the different products and systems out there. We compete very, very well there. So we can withstand significant hydrostatic pressures. Now, again, it comes down to your design. I'd like to see more of the joint details and stuff. I like the bathtub. You alluded to the bathtub. I think HDPE liners are very difficult. They're very expensive. If you have a thick mat raft slab and you have enough steel in there, or even if you do get some micro cracking or something, you can hold it together. That's a wonderful area for us. If you're in water table, you might need to do the whole raft. If you're up above water table enough where it's more of a seasonal thing, you may do the bottom foot or two of your mat raft with, say, Chem Concrete. You may do the upper foot with Chem Concrete. You have some options there because, yeah, that bathtub design, as you put it, kind of a boat, very difficult, very expensive, and particularly areas, again, where it's maybe more of a damp proofing, seasonal waterproofing. We've had very, very good success areas like that.
So the feather edges, they don't line up. You can imagine how that might look in 3D, but it's quite a cost-effective system. It's called FEBTU lock. It's on footprintengineering.ca. Dante and I did we went and rented some office space to try and do some videos. We're going to have to do that again, Dante, because I have
Okay.
a better file
Oh, okay.
that would, and rather than, we ended up using Mohammed's,
The PowerPoint.
yeah, the PowerPoint, which wasn't really construction knowledgeable.
Okay.
I mean, it looked good,
Yes.
but the slides looked good, but it really just had the acronym name. It didn't have the my details are quite well thought out on all this stuff.
For sure.
This is
Well, I
the
love
only
it because
patent.
they have both metric and US imperial. So, as self-centered Americans, we got to throw some inches and feet in there.
My probably my best patent, Boris and Jim, is the geothermal. So I have a drilled shaft geothermal that runs on water, and it's got twice the performance coefficient, what's called a COP. Got a COP of 5. And the standard geothermal using glycol is 2.5. So you could put in, let's say, a 2.5-ton glycol unit. In Toronto, geothermal is pretty big. And it takes 1 day to drill that hole. And that hole's 300 to 400 feet deep. And then it's glycol, which isn't friendly to the environment. But with my technology, FEBTU cell, and I could put a windmill on it. I actually have a nice order coming up not far from here. And I can put a windmill in. I'm the only geothermal that you can put a windmill in. So the windmill generates 5 or 10 kilowatt, depending on the high pole magnet motors. And I just thought that I would mention that geothermal because I have my patents, my energy patents. I have them in the States as well. So Jim, we'll have to get you familiar with the geothermal and somehow involve you in that. I mean, right now I'm chasing down Keller. You're familiar with Keller? They're a pretty big geotechnical.
Very good company, yes.
And they have
Martin, is your patent in the fluid that goes through the circulating, or is it in the system itself?
Well, that's interesting. It's actually in the system of evaporation. So there's nothing better to evaporate. I don't have to worry about circulating glycol. I can evaporate the water. And when water evaporates, it's 100 BTUs per pound, 150 BTUs per pound. So it's strictly do the math, right? But I can scale my geothermal. So I can put in a 30-ton geothermal unit, and I can do 5 a day with a caisson drill. So my background's caissons, right? It's special foundations. It's I created a big company, and they kind of stole it off me. But nonetheless, life's good. I'm not going to complain about them or mention them right now. But the Jim would remember some of the stuff I did before. On mixes, I was working with basalt and colloidal silica. And I think that's a space that you guys are going to run into lots of people who want to use colloidal silica. I mean, you got that company E5, they sell colloidal silica. And I did some patent pendings on mixes with that until Chem Concrete came out. And I was really keen to say, well, that's the Cadillac. What Jim and Boris have in North America will, with time, take the market. However you mix and match it, right, Boris? You know it's going to take some time. But it sounds like you guys are the right people to be doing it. This is a world patent. Chem Concrete is a world patent, and that's quite rare. Kudos to Sam and, like you say, the Iranian engineers. I mean, when we talk about Iranian engineers, they're sure giving Donald Trump a hard time with his.
Anyways, I want to bring it back to when we were talking about how dense the mixes are and how impermeable they are in the water beads. There's a whole other application that we haven't touched on yet. And that's sort of more in the retail market when you're looking at pavers and masonry products and the challenge of efflorescence that occurs in architectural precast. By using Chem Concrete, we lock that all in.
Yeah, I'm not sure. Why don't you explain some of your background, Boris, for people that are listening? Boris owns a precast company, so he's an expert at precast. And you seized, when you heard about Chem Concrete, you seized that pretty quick in terms of understanding its uses. So are you doing precast that beads water?
Yes.
Potentially. You do.
Yeah.
Which is
So the point is that there's many applications in the world of concrete. So we were talking about ready mix specifically, but I just wanted to share that we can also expand that into the precast world, into the paving stone world, into the masonry world, any type of concrete application actually.
And I think that's important too, Martin. Yeah, that works worth repeating. Exactly what Boris said, because of all the things we talked about, right? The pozzolanic nature of Chem Concrete, the nano micro filling nature. There's a rheology feature too that I would point out really in two main things. One, what Boris said. I talked to some interesting, I won't say the name. They're a very, very large precast company in the United States, big on the West Coast, but they're pretty much throughout the United States. And there's a lot of tectonic kind of plate shifting. Again, I don't want to be super dramatic, existential, tectonic. Those are my super drama words, but there seems to be a lot of the teams are kind of getting reorganized quite a bit. We've seen this before. I've seen it in my lifetime in the 80s. My father worked for Kaiser Cement, and instead of having all those fancy salesmen with the company cars and the big expense accounts and the beach club and all that, they went vertical, right? They went and they bought, well, first Mitsubishi bought Kaiser Cement. They bought Robertson's Ready Mix. They bought Nevada Ready Mix. And that's the natural outlet. So they only got maybe one or two salesmen, right? You need maybe a couple precast. Precast is good. Precast is always consistent, right? It's not big, it's not sexy, but every month it's just X, X. And you might have a tail off in December, right? We always talk about that. And this December is great. And then the last 2 weeks, everyone disappears again. And they come back about the first, second week of January. But for the most part, precast guys are pretty solid, not glamorous, not sexy, but they're always consistent and they're using so much cement. Freeway guys, right? Our freeway guys out here, they put up plants. So, you want to get in and sell them some powder. But for the most part, most of the big cement companies we see are vertically integrated. They have their outlet through ready mix. This is getting even bigger. I see companies like CRM who are going across vast spectrums where they're looking at bag mortars, or looking at ready mix, fly ash now, they own Eco. So think about that. If you're a competitor of one of those companies, do you want to buy fly ash or pozzolan cement from your competitor? Maybe, maybe not. But we can compete in that area. So if you're a guy and you're running a major precast plant like what Boris does, you only have so many options, right? You have your 1L cement. You might look at Pozzolans. You have fly ash. Well, in my neck of the woods, fly ash is hard to come by. Good fly ash, probably even harder to come by. You got to look. You got to turn over some rocks. You have slags. Slags have a certain amount of baggage. There might be relevant. There's different issues that come with slag. But your other option, of course, is the silica, right? We've talked about silicas here. That's where we play. That's where we come in. So we can almost take that silica fume like, and again, we get rid of all of the big obstacles, right? It's not airborne. It's not going to cause cancer. It's not going to cause respiratory issues. We're liquid, so that's off the table. We've calmed it down, right? There's not some massive water demand with silica fume like the old days. In fact, we got a nice plasticizer package. So that's really the issue is precast. They need strength, right? The sales guys, they think it should take an hour, right, to cast a vault and sell it. Why does it take you more than an hour, right, Boris? If you're a sales guy, hey, you're slowing down, man. You're not doing your job. What's the problem? So if you can break your molds down in, say, 24 hours as opposed to 36 hours or maybe 18 hours, that's a good day. If you can reduce your amount of breakage by the time you pick something up and you put it on a truck, that's a good day. If you don't screw up and you have to come back and put some silane, siloxane coating on there, that's a good day too. So we have I think between the rheology, that kind of high range plasticizer package with our silica technology, we have a very good value proposition as Boris said, directly in that precast range. And I know we've got a lot of big companies kicking the tires right now today, testing it, and we're very, very excited. The other issue is William Chen. William's been pretty quiet, but shotcrete, right? Structural shotcrete. There's another area. You can, not to diminish or demoralize anyone, but you can do a sidewalk and you can wait and you can screed and float and put a nice finish on it. And it's pretty common and it's not that big of a deal. You do shotcrete, right? You do one-sided forms, boy, totally different space, right, William? You better have your mix dialed. You want it leaving the plant at 4 inches. You want it coming in at the back of the pump. You got your big, beautiful Warrior or whatever pump you're better be 3 inches, and that goes through, 150, 200 feet of hose coming out at the nozzle a certain way. You got one way. You stack that concrete on a wall, man. You don't have a lot of room for air. You get some dirty sand, some sand that maybe the guys are recycling, some wash con sand or something, man. You lose walls, man, the phone's gonna ring and life sucks real quick.
Yeah. Can't get it through the pump, stuff like that.
Can't get it through the pump. You got high sack mixes. Yep, something breaks down. Trucks aren't, are waiting for trucks. I've seen that. Man, you got some unhappy campers, right, William? Beating it there with the biggest hammer you can find. So we've taken, besides the precast, I've spent my initial stuff here I'm doing with my old, and again, it's a tight universe. Hell, I think William bought a pump from one of my good friends that I go to the gym with and hang out with. It's a small space. So if you can get that Chem Concrete to react in that mix properly, hang on any one-sided form and finish it tight and get out, boy, that's a good day. That says a lot. Anybody, not being slightly facetious, anyone can finish a slab, but you get up structural shotcrete, heck, you get into overhead shotcrete, man, not much room for air there. And we spent a great deal of time and we handle very, very well in some of those shotcrete mixes. High cement, high pozzolan, 1L might be an issue. There's all kinds of things. And we like it. And more importantly, the customers like it. So
It doesn't affect the finishability of it at all.
It does. It finishes it favorably. One, we use some of the water, right? Because all the silicas Martin keeps mentioning. And two, so we have more fines, right? Again, I don't want to sugarcoat, right? That's the first way you can tell an admixture guy that's never been in the field. Well, finishers love it. Finishers don't love anything. I don't think they love themselves, but that's another conversation for another time. But they're not going to complain. Again,
no comment.
Margins, yeah, it's finishers love it. Yeah, okay, buddy. Yeah, so you've never been on a job site, right? Finishers love a good lunge. That's what I like to say. And
well, I know, like some admixtures, they don't blend evenly into the concrete, so when you're trying to finish, it comes out all weird, right? So some sections of the floor is all of a sudden finishing.
Absolutely. I think a lot of, not to take a backhanded slap at the crystalline growth guys, but for a long time, they tend to accelerate the mix. So you need to slow it down a little bit. Well, how much do you slow it down? Well, I know one of the companies has like a winter blend and a summer blend. Well, not to be a dick here, but we have no winter. The other day, we had a heat storm come through and Boris was on the other line on the call. And like, Jim, we had 2 feet of snow. Half of my sales force isn't coming in. And it's like, there's no such thing as winter in Southern California. So I think, again, when you get into the rheology of a shotcrete mix, very, very critical. And we'll do one. We'll use some of that extra water, William, and we'll give you more fines. So the guys will get a nice, there's guys, you can put finishes on them, steel trowel. You would bet your life that that's a 2-sided form. And it's simply structural shotcrete. We'll help that. We certainly won't hurt it.
Would you call that plasticizer, Jim? You say it's a good plasticizer?
Part of it. Yeah, but again, William knows you don't want too much plasticizer because no matter what anyone tells you, it's non-retarding accelerator. Anytime you put that much plasticizer in, you're slowing things up. And William wants to shoot his 12, 14, 15 loads. He wants to go home. He doesn't want to be there till 9, 10 o'clock. We don't.
No, but what I'm saying, Jim, is Chem Concrete not plasticizer like? I mean, because of its
Oh, no, it
fines.
has a very definite plasticizer package.
So you won't
too.
need a plasticizer, right? Wouldn't need one.
You'll need less. Yeah, again, I want to be careful with that, Martin. But yes, undoubtedly you will need far less plastic. If you have just a little bit of low range in there for the help the workability of the viscosity modifiers, things like that, yes, you could probably eliminate it. If you have a whole bunch of like some of my Shotcrete, or excuse me, my precast guys, they're using massive doses of Super P. It's almost like an SCC mix. Yes, you can reduce half, maybe two-thirds, all depends. You got to kick the tires. But yes, you can greatly reduce and in some cases eliminate a lot of your plasticizers with Chem Concrete.
Like it sounds to me like you guys have done a lot of research on this, obviously. Now, I don't know if you guys have this in California, but in Canada, we have this new concrete called environmental concrete. I don't know what the technical
What are the
word
rabbit
is,
ears?
but
Yeah, I don't know what the rabbit.
yeah, because they call it environmental. But from what I was told in the beginning when I first seen this concrete last year or the year before, it's actually environmental because they chop up things that can't be buried in a normal landfill, like rubber tires, for example. They grind it all up, they throw it in the mix, and then when we go to use it, if you put it down and you wait too long, it hardens up and you can't even finish it. Like, I don't know if you guys deal with this kind of stuff, but they call it the environmental. So all of the government buildings and all these buildings are using this new concrete because they get a kickback from the government. Okay, so they call it environmental, and I was just wondering if your mix will mix, like if the Chem Concrete will go into this environmental stuff, it'll go into any kind of concrete. You just got to kind of play with it a bit.
Excellent question, Brian. And yeah, there's a couple answers there. I know I spent some time with the guys at Beltertech. They got this synthetic aggregate association up and running this last year. Did a really good job. Kevin Shepard mostly spearheaded that. Jerry, good guys. So we got to get to know some really good guys doing that. There's some guys taking some polyester foams and they're breaking it down into an admixture. They get a little bit of air, some lightweight properties. Got some other guys are taking plastics. These kids are going out in the oceans and rivers and collecting these plastic bottles, trash, heating it up, hitting it with some potash. It turns into a halfway decent kind of medium fine aggregate. Love that. Got a whole bunch of those. Travis, they're using some glass. Again, I love that. You're absolutely right, Brian. It's a little bit of a shell game. There's some, credits. Uncle Sam. It's big. It's nothing to be trifled. I was at a thing here last year, and that was before the previous this current administration. And there's a gal from the Department of Transportation. They were talking like billion, and you could just feel everyone the vibe in the room. There's some serious money there. So again, I don't mean to be trifle or dismissive. We like that. We like that area. I think, again, when you can do what we can do, a lot of people are reaching for that. I know Travis came at me the other day, did some mixes with his glass. He's like, Jim, we really liked it. And they're taking it to the next level. There's some precast, there's some concrete. I think we're still a little ways away in big structural concrete. I know I did something years ago I was proud of. I worked for a recycle company. It was both concrete and asphalt. They turned it into class 2, kind of a crushed miscellaneous base. We used it not in concrete, but lean concrete base. George at Flatiron, brilliant man. They did some quite a bit, 70,000 tons worth, where they took both the concrete and the asphalt and they used it as an aggregate in their lean concrete base. Very low PSI, but still, it only been done once before at a very small level in California. Knocked the air down,
That's
obviously.
like a refill. What do you call it? U-fill. It's like U-fill. Is that what you mean? We call it U-fill here. It's like a very light
Probably.
MPA that you can use as a base. You know what I mean? Especially if you have to redig it. So that
Well,
the
that's
wall
more of
won't
a
collapse.
flowable fill. That's a little different, similar, but that's a flowable
Mhm.
fill, we call it. Again, lean sack slurries and stuff like that. This is we're trying to improve. We have a lot of clays here, and then we have the earthquake thing, right? So it's a tough slog sometimes in California. So they're just trying to improve their sub base. So they'll go dirt, and they might even
Yeah.
compact and stabilize that. And then it's a sub base on top of that, a lean concrete base put the concrete on top of. But you're right in a way. It's in that vein.
Yeah.
But I think anytime you get to a circular economy, this cradle to grave thing where you can recycle it, again, you're absolutely right, Brian. That's the future, man. That's where this is going.
Mhm.
And yes, again, I wouldn't just say a blanket statement, just add the Chem Con, because then I sound like a snake oil guy. But there would be some significant benefit, right? You'd want to take a look. Where do you want to get strength wise? We find that you do not need like a viscosity modifier and some of the other drugs you have to throw at something where your gradation's off a little bit. Big fan of Tyler Lay and the tarantula curve. For the most part, that's a pretty good, you want that distribution. Yeah, there's a few parts of the country. I know Utah's got some very unique aggregates. Hawaii, very unique with their local sands, coral sands and stuff. But for the most part, absolutely. We would love to look at that. We will get your margins, your distribution far, far greater, I think, with our admixture. If whatever you're taking advantage, those boxes that you're pulling from us, whether it is the plasticizer package, the nanosilica, the particle packing, the extra strength, the workability, the rheology of the mix, we definitely got some value there. So absolutely, it's good stuff.
Yeah, it's a game changer. No
Yeah,
doubt about
and
it.
then in a nutshell, I would just describe it, Brian, as we're complementary to
Uh,
what the mix is that you've described and Jim's talked about.
Because you're right,
You add,
with the
yeah,
rabbit ears, right? The carbon credit market is substantial. I've,
Yeah.
whether it's through the LEED program, now I chickened out. I didn't take the LEED test. They changed it up a little bit. I did take the Envision SP. Same kind of, that's the engineer's version of the LEED. Uh, had to really actually try hard. It was a tough test, but I think, let's face it, I'm an old man, right? Again, right? I'm fat and old. I'm 60 years old. I go to a lot of these seminars, they talk about clinkerless clinker. Well, I hope so, God willing, but probably not in my lifetime, at least not in my career span. So Boris and I joke about it. Boris, we've been on the same page, but yeah, we want to look at something within a certain window. If you had a project where you say, hey, I've got to get down to that 35%, as you said it, the environmental, and there's different coins, different people. Obviously, I live in California. It's front and center in everything we do. Uh,
Definitely.
we can play. We raise our hand and we would like to be invited to your party and we would like our 15 minutes to deliver our value proposition. Is it right for everything? Probably not, no. But there's probably where we have some value in that conversation. Whether you get it back in a carbon credit from Uncle Sam, the USGBC, United States Green Building. I spent a lot of time there. Some great ideas, some wonderful, smart people that are moving that. But yes, we feel that today, relevant, timely, substantial, absolutely.
Mhm.
Yeah, just to add, just using the Chem Concrete on its own in a conventional mix, Brian, you could call it an environmental mix just because of the carbon savings.
Mhm.
because of the cement reduction, right? You know what I
Exactly.
mean, Boris? Yeah.
Exactly.
So you would
Yeah.
mix it. You would mix it directly with aggregate, or would you have to put concrete in there as well? Like you'd have to put the
Oh, yeah,
lime or whatever.
limestone is high value, like limestone. And the granulars, the quality of aggregate is very important for any concrete. But as the precast guy,
Yeah,
I
so
know that.
let's not let me give Brian a little background again, may or may not be aware. So right now, Brian, the Cadillac is right. The super cool, sexy technology is this 1L cement. So you can take up to 15% of the limestone out, right? So you have all your Q goes through the preheater. You have clays, you have irons, you have limestone. You've got a number of things. You preheat them. You get them in a certain Q where they come in at a certain quantity and rapidly go through the kiln, right? And that kiln just sparks up to about 3,000 degrees. So we're taking up to 15%. Might be 7, 8%, might be 11, 12. I think in Florida they have like they call it a 113, an L13. So got to assume 13% limestone. And then you're grinding that limestone on the back end with the clinker, the gypsum, and the limestone. So that's where we get the 1L thing. That's the Cadillac. They say net maybe 2% less carbon because most of your carbon dioxide comes off the limestone when that gets superheated. So when Boris and I walk in the room and say, hey, we can go up to 35% of everything, your 1L, your Turner, all of that. There's not a lot of guys in the room. There's not a lot of people raising their hand. There's a lot of cool stuff coming. There's some neat stuff. You know, a lot of people can get 10, 12%. You cure concrete a certain way, you get some advantages. But to walk in the room and say, hey, man, you can take out a third of all of your cement and let's redesign the mix around me, my product, my performance. That's a small crowd. There's not a lot of people riding that wave.
Mhm.
Jim,
add it to
ahead,
everything. You could basically add it to everything. If you wanted to do sidewalks with it around your $1 million,
I like where your head's up, Brian. Yeah, let's just put it in everything. That works. Let's do that. Yeah.
it just makes it a better product. No matter what product you're adding it to, you just have to change the recipe, but you could basically add it to any kind of concrete that's out there. Cool.
Yes,
cool.
that's like I said, I think you have to look at all your constraints on a job. But like I said, I think what even Boris and Martin touched on in Williams' world there with the waterproofing, definitely damp proofing, definitely belt and suspenders. There's a lot of booms that are very sensitive. So even if you put a conventional membrane up, don't forget membrane, the best day of a membrane is whether you peel, stick, you spray, whatever you apply, is the day it goes up. That's your best day. Then everyone builds around it. I always love Grace and these Setco, Trimco, wonderful people, but they always got this super clean, sterile job site. Well, I go to job sites every day, and my job sites don't look anything like what they have on their brochure. The steel guys there, the excavator, everyone's there working. The backhoe bounces into it. Crete used to have a really nice picture of backhoe, just scraped it, and everyone points and looks at it. What you never see is that guy coming back to fix that. That's the thing. And if they do, it's probably more of like labor material. Not that there's any, God loves laborers, but you're not talking about highly skill here. The best day is when that membrane goes up. Boris and I, our best days at 28 days, 56 days, we get better. We make more calcium silicate hydrate. We make more secondary cement as time goes on. We're only getting better. Our watertight, we might be at 92, 93% at day 7. I'm going to be at 98, 99% at day 56. So we get better. We got a big advantage. Those other guys, that's a labor intensive. When you start talking like Martin here, eliminating trades, I don't know, any superintendent says, no, I love my waterproofer. I don't know. I'm sure there's never say never, but it's a
in
tough
Toronto, it's a 1-year warranty. And that's,
Yeah.
I think, no, maybe 2 years, and that's membrane, right?
Right.
So with
And I mean-
Chem Concrete, you could increase the warranty to 5 years and
It's
just watch the
integral
details. Just put the QA in it, right? Make sure that people are doing this shotcrete properly. That's why I think my FEH2 lock has a big potential, and William and I are just.
Martin, I think you're absolutely right. I think that's the pre-con, right? So we make the concrete waterproofs, and then you have to start thinking about where there is no concrete, right? A joint, a crack, penetrations. I think I like to approach it this way. Here in Southern California, there's some polyvinyl dumbbells. There's some really neat synthetic swell stop material. Bentonite only kind of moves and contracts for so long, and I think it breaks down. So our thing is hey, maybe look at us as an admixture, an integral approach, And then let's take some of that cool, sexy stuff that has always been out there. You always wanted to use, you couldn't really afford it. We're going to save you enough money where you can go back to that. For someone like William, let's tie some dumbbells in, right? Now, again, he's going to shotcrete, so we're going to have to put some pig ties or some, maybe a little more often stuff, tie in a, a footing into a mat raft slab into a wall. But there's going to be still lots of money on the table. If you use Boris Naneff admixture, you're going to be able to afford those cool, sexy things. Some of those cowbells, some of those dumbbells and stuff that you can tie in that are good to go. You get the consolidation right. I always say, right, the big guy with the vibrator on those structural crews, he gets the biggest burrito, man. You got to make him happy. That guy, Murtash had that on the other day where he's got the little plastic cube and they have a half a cubic yard of concrete and it's all voided and the guy puts a stinger in and poof, it's like magic, right? Perfect consolidation. That's the dude on the crew you buy the biggest burrito for, right? The guy with the stinger who's vibrating that concrete. Nobody more important in the world than that guy right there, no matter what your mix design is.
Yeah, very good. Well, listen, we should do a part 2, and I'm going to suggest, Jim, that this has been very good. I think you guys can use it wherever you can on LinkedIn. I'm going to see how much interest I get on it. I got about 7,500 followers. It's nothing like Murtash, but I spend a lot of time trying to push my patents on
One of
LinkedIn.
the nicest man on the planet. Yeah, Professor Murtash. He's a unique guy. All of Sam's crew, him, his wife, his crew, just wonderful people. Our hearts go out to Iran and what they're going through, and hope they turn that boat around. So,
yeah, I think they are amazing engineers. Anyway, Boris, thanks very much for joining, and let's do a part 2. Maybe with some data, like maybe you could do, because you guys have a lot of specific. If you prep for it, Jim, you can share. We can share your actual test results.
Hey, one more question. Are we able to mix Chem Concrete? Are we able to mix Chem Concrete with certain epoxies? Or is that a different family? Can you mix it with, how they put epoxy floor with a little coating and stuff? Are those two mixable? Can you mix that, or is that different properties? Can you use it like an epoxy?
You wouldn't put it in the epoxy, Brian. That's a good question. If you want to put Chem Concrete in the concrete and properly profile the floor, and then obviously, like anything else, you do the water droplet and you see if it's absorptive, non-absorptive surface. Absolutely.
Can you replace epoxy? Can you replace it with that maybe instead of putting epoxy down, put Chem Concrete with color in it, for example?
That's a good question. You can replace a sealer. Let me answer it that way. So if you're going to put concrete down and you feel because of the harsh environment surrounding that concrete and you want to put like a siloxane, some type of coating. I know Tyler Lay, those guys, they do some great testing on that. David Trejo, Jason Wise, where you look at, again, what are they trying to do? They're trying to disrupt that top half inch of the concrete, the capillary system, and interrupt that, abbreviate that right at the surface. Yes, then you could look at eliminating that, because we will do that triaxially, 3-dimensionally, all the way through the concrete. You got to start at higher dosages of what Boris and I are looking at when we do these cool, sexy things, replace all the cement. You got to start thinking more in terms of like a plastic. We're changing dramatically the inherent characteristics of the concrete. So absolutely, you could forego a sealer. Now, epoxies for different things. There's some cool, sexy ones that look really neat. But yeah, I'd want to know a little bit more.
Yeah, and just for the color question, Brian, to add to that, we could put the pigment right in the mix, and you get the colored concrete delivered.
So basically, you can cut out, like if I was going to do, I know this is maybe not the right application, but say I was going to do a stamped driveway. When we do a stamped driveway, we have to add the color, we have to seal it every year, we have to do all that jazz. If I just put Chem Concrete in, I'll never have to touch it again. Does that make sense?
Correct. Yeah,
absolutely. You could probably put, Yeah, I do some custom stuff on the side. So you might want to put like some cheaper stuff on there just to get it to pop, that wet look perhaps. But absolutely,
Yeah.
as far as protecting that concrete, the use of Chem Concrete. I think the other thing too is very subtle. We didn't really touch on it, but like the rheology, like Boris said, it holds the color that much better. You know, a big part of the 1L wave of people being upset and stuff is you get that separation, right? You get that uneven bleed. We eliminate a lot of bleed, so we take a lot of that off the table. So if you want to come back and say polish that concrete, what you want a perfect distribution of aggregate, right? If you want that canvas to be perfect, we help with all of that. It is superior rheology in every facet. So come back and polish it. If you want to stamp it and color it, absolutely. That's all enhanced with Chem Concrete.
Wow.
Those are great points, Brian.
Thank you. Yeah, because I'm just seeing what I dealt with out in the industry and then listening to you guys. And then I'm like, wait a second, we could just, so after listening to all this, it just makes the product that much better and universal. You can use it in so many ways.
Well, we appreciate that because I think, Boris, what'd you send Brian, 5, 6 totes to his house tonight? So I'm glad that you're thinking positive. That makes it a lot easier to break it to all you guys. I don't know why you're laughing.
Don't worry, I'm a great salesman too. I also have stakeholders.
Well, you guys all got 10 totes to be at your house tonight. No, seriously, it's been a pleasure, guys. We appreciate it.
Brian, make sure you tell your boss. You know, you've got a crew going.
I have another. So I have a friend of mine. His name is Bill Medeiros, and he invented an epoxy that's food safe. And so he would put the epoxy on the inside of the silo, you know, like the grain silos. And he put the epoxy on the inside. It's food safe. Even if the outside deteriorated or rusted away, you would still have this interior shell, right? So he sold his patent. He bought a Viper. So, I mean, he did okay. But, you know, yeah, it's almost kind of the same idea. Now you could take this and you can replace things like epoxies, and you can replace other like sealers and stuff.
Like NSF 61 and stuff like that. Yeah, we're applying for that now. Absolutely. So we would benefit the silo, and then you put Bill's epoxy on. We're talking about like 200-300% tripling lifespans, life cycles of some of these plans. We want to get into stadium and some of these life cycle models because we have a very, very strong. Any corrosion that's coming in, right? That's all because of the way concrete cures, dries, and hardens, right? That water leaving the matrix, we stunt that right from the start. So all of that becomes very, very attractive. You're absolutely right, Ron. Yeah.
You even see it in bridge design. Like if you go to Toronto, you'll see the Gardner. It's always under repair. They're always breaking out sections. I mean, you could replace all this with Chem Concrete, and you can save tons and tons of time and money and resources. And we could actually, instead of repairing our infrastructure, we could actually just concentrate on building new stuff because the old stuff isn't breaking. By the time we turn around, we look, it's already got a crack in it. You know what I mean? Like our
Amen, brother. Yeah. I love that. Absolutely.
Two things, Brian. Two things. I'll ditto what you said. Build it right the first time with Chem Concrete, right?
There you go.
Second thing is Chem Concrete can also be used in that repair material, which will make that repair last even better.
Yeah. The Gardner falls, but all the repairs are still there. Yeah. Everywhere Chem Concrete is good. So I think this is something that would be really good for infrastructure for everything else. Right? So
absolutely.
It's just the whole thing is the reason why they're not using it because they don't know yet, or is it because they want to keep charging the customer for repairs? Do you know what I mean? Like, it gets back
I like to think the former, but yeah, Boris and I, we're busy guys. We just brought a national guy on. He's actually going to be international. He's an ex-flooring guy. You mentioned flooring, somebody earlier. FST, they're big in the flooring space. He does exactly that. He gets in front of guys 24/7. So when Boris and I are busy, and that was the other thing with the Chem Concrete we made, right? It's very white. It's got almost like some titanium oxides to give you that white tint. Everyone loves white cement, white concrete. So when we're up to our elbows making this crap, we got one guy out there selling, but you're absolutely right. It's an education thing, and we're hoping to educate folks, trying to give them an underhand pitch. We don't want to come on strong, but yes, we have some value, and we'd love to meet at any point in your project delivery team. We get along with architects, engineers, big sexy general contractors, obviously concrete installers. We're like relatives. At any point, your project delivery team, we'd love to meet with them and see if there's some value there. Absolutely. Couldn't say that loud enough.
Right on. And appreciate the invite, Martin, for the podcast.
Martin, it's very nice of you. Thank you. Yeah.
Let's do a part. We'll do a part 2.
We'll fix more of the world's issues. I love that. Yeah.
Yeah, I agree. Thanks a lot, guys.
Baby, I need to know